Hello. In the previous video, I explained how we can implement the fixed effects model. So the basic idea is to cancel out the fixed effects because there are as many intercepts, as many fixed effects as the number of entities, or state, which may be states or number of individuals, households. So it could be quite a huge number. So then it is inconvenient to estimate all of them. So that's the fixed effect model and how we implement that. And on Stata, you have to so now the on Stata, the first thing you have to do here is after loading the data, you have to tell the program that the loaded data is a panel data. So you have to tell the structure of the data here. So you set xt set. It's called xt set. So xt stands for panel data, and setup is so there are in your data we tell the program that state is the first dimension, the entities, and year, the variable. Year variable contains the time periods. So say state variable will be like 1, 2, 3, 4, 5 up to 50. So each number is just the identification of each entity. And also year will be 1982, 1983, 1984 up to 1988. So it also tells the program that this is the time. Then, so this is result. So if you type xt set state year, then Stata understands the panel variable is state, and it understands it's strongly balanced data, and it also understands the time periods are annual, and from 82 to 88, 82 to 88, and delta increment is 1 year, 1 unit. So 1 year. Sometimes, like if your observations are like every other years, then it will also automatically understand the increment delta is 2 units. It's very interesting. And then after you set xt the panel data structure like this. By the way, I am going to demonstrate this like with the homework, so you don't need to take a note on this command. I will show you how to do this. Just I'm explaining how the program understands the data when you implement it. And after you let the program know about the structure, then the regression command is not just a simple regress, but you have to use xtregress, xtreg. Xt regression is like panel data regression, and VF are all is fatality rates in state, and beer text. So fatality rate is regressed on beer text, comma, we put option FE. FE stands for fixed effects. Fixed effects model, FE, and the variance option is, so variance covariance estimator option is used cluster state. So within a state, the previous year's fatality rate, the previous year's error term may be correlated with the following year's error term. So state is considered as one cluster. So within a cluster, the error term may be correlated. That's what it means. By the way, you don't need to care too much about this. I think robust is still fine, or so just use cluster and the panel data variable, the panel variable. So the reason why they include this is because this is kind of the standard these days. In the past, the variance metrics, variance estimator was not seriously considered, but these days, if you're using cluster variance, then people think you know what you're doing, something like that. So you know what the the mainstream does these days. So, but if you do not understand what it means, then don't worry too much. Just like when you do the coding, just put this line. That's it. Anyhow, then it will estimate fixed effect model. The point here is this. This without this option, the regression is working, but you need to include this. The most important part here is FE, fixed effects. Then it includes the fixed effects, but it does not show the results. How the intercepts are estimated. What are the state-specific fixed effects? Because it's cancelled out. In the end, they are all cancelled out, and you only observe the coefficient of the Beer text, and this constant is the average of all averages. So the average of all intercepts. So intercepts may be different across states, and this constant term is the average of those intercepts. So not so important. So anyhow, we are interested only in the effect of beer tax on traffic fatalities. Now, as you see, it's negative, and the p-value is 2.9%, or t-stat is minus 2.25, so it is significant. Significantly negative because p-value is smaller than 5%, or t-stat is smaller than minus 1.96. Therefore, as we expected, higher beer tax reduces traffic fatalities, which is reasonable. It just I don't know how big the impact is, but anyhow, we have some significant result consistent with our conjecture. So that's the result, final result we get here. So I explained almost all the things, and the details will not be covered right now. So I will also, of course, I will demonstrate this in the homework. So don't worry right now how to do this. The point here is I just wanted to show you the results. Fixed effect model, there are hidden 49 49 intercepts which are different across states, but they are cancelled out and they are not shown here in the results. Okay, and so results are given like this. And should we report the intercept? No. So I mean, this intercept 2.377, it means pretty much nothing. So it doesn't mean anything. So I don't think it's important at all. It's not important at all. But if you are interested in some specific states, then you may consider like reporting the intercepts, the specific intercept, but then you cannot use this code. So the reported intercept from the fixed effect data code does not mean anything. But if you are interested in a specific intercept, you cannot use this method. Then if you want to use the binary regressors, dummy variables, you have to include here. Originally there are 48 states because we excluded maybe Alaska and Hawaii. Then you have to include 47 dummy variables. So if you report the full results, there should be 47 more rows, parameter estimates to report, but they are not that important, so we are ignoring them. And also, you may compare this to the changes estimator I introduced earlier using only 2 periods, first and the last years. And that was also negative, but now we have a better, more significant and stronger effect using all the years, all the time periods, because we have more data. So of course we will have a better excuse me, I mistook. So the effect of beer tax was minus 1.04 and 0.36, and now it's 0.66. So these two are the effect of beer tax now and there, now and there. And so it includes the intercept, but it doesn't mean anything. It doesn't mean a lot. Anyhow, it should be 0 in that example. So that's what I mentioned in there. But it's so like this is not important. Our intercept is not important in the fixed effects model too. And the slides have a table of beer taxes over all the states. I don't know why they are showing this. I don't think it's important. We are just considering this as an example for fixed effects model. If you're interested in like liquor stores or like business in liquor stores, maybe you may be interested in this, but I'm not, so I will skip that. It's interesting. There are details, but that does not say a lot. And then let me now. So, like the motivation of the fixed effects is that there are hidden factors specific to a state but does not change over time. But in the same way, similarly, we may consider some hidden factors that is specific to a time but does not vary across states. For example, this interesting example is that, like, suppose that within our observation periods, 1982 through 1987, at some point, suppose that airbags are required by the national law. So, say, I don't know it. I don't know when it was exactly, but suppose that airbags are required, then it will have huge impact on traffic fatality rate, and it will have maybe the same impact on all the states because it's national. So then, however, it is not captured by the state fixed effects because it's not about one state and it changes over time. So before the policy change, the airbag policy change, the traffic fatalities must be lower, like higher, but after the change, it will drop. The fatality must have dropped because of this change. So in that sense, it changes over time. So it does not satisfy the fixed effects assumption. So to handle this, how can we do this? You may consider the mirror image of fixed effects. So fixed effect was specific to a state, but consistent, does not change over time. Now I will switch the roles. There is a hidden impact that is specific to a certain year, right? It happens in a certain year, but it happens to all the states. So all the states have the same impact. So now, right, it's specific to time, but same for all states. Previously, specific to state, but same for all times. So it's exactly the mirror image. And then we may apply the same idea. Like now, we denote it as ST. So ST is another hidden factors, and it changes at a certain point, but same for all states. Then you are going to get this kind of regression model where you have state specific fixed effects. So it depends only on state. But there is another S which depends only on time. So this time, I'll say this S equals to 1, ST equals to 1 if airbags are required. Say, I'm not so sure, but suppose that airbags are required since 1985, for example, then 82, 83, 84 will have 0, but 80, 85, 6, 7 will have 6, 7, 8 will have 1. So in that way, S may change, or you may think S is the percentage of cars that have airbags, for example. So, and then again, I'm explaining as if we observe this S, but you don't need to. We don't need to observe this. There may be a lot of different hidden factors that have similar properties. Then all of them can be included into this S, no matter if they are observed or not. So I will explain, and you can expect that we can do the same thing for this guy. Yes, we can. I will explain that in the next video.